In this, I am explaining the equilibrium curve and TXY diagram. The important rule is the Raoult's law. It is applicable for the ideal system. In a binary system with two components A and B, Raoult's law can be written as PA is equal to XA into PA, where PA bar is equal to partial pressure of the component of A. According to the Dalton's law, sum of the partial pressures is equal to total pressure. The partial pressures can be calculated by using the Antony equation, that is log P is equal to A minus B by C plus T, where P is the vapor pressure, T is the temperature, A, B and C are constants for specific component. For example, for the water, the A value is equal to 8.07131, B is equal to 1730.63, C is equal to 233.426. The boiling point temperature for a partial composition, say 0.1 mole of more volatile component at constant pressure, calculate the corresponding vapor pressures and partial pressures of the component at a particular assumed temperature. If the sum of the partial pressures is equal to the total pressure, then the temperature is called as boiling point. If it is not equal to total pressure, by trial and error method, calculate the appropriate temperature such that sum of the partial pressure is equal to the total pressure. After getting the data, draw the diagram between the X, Y and temperature. That is, an useful diagram is the temperature versus composition diagram at constant pressure. It is obtained when the above represented data on the compositions are reported versus temperature. So, we will observe that three type of regions, that is here the liquid phase region, here liquid and vapor region and vapor region. So from this diagram you can say that there are three regions are there in the TXY diagram. Moving from the higher temperature, that is T1, where only vapor exits, to the biphasic region at temperature T2. A certain amount of vapor condensate, the two phases liquid and vapor coexist at equilibrium with a constant of more volatile component respectively on liquid and vapor phase, which can be read on the liquid equilibrium line and on the gas equilibrium line. Drawing of equilibrium diagram, that is XY diagram, you can also call as XY diagram. From the data you can draw the liquid composition X, the vapor composition Y, and you can represent in a diagram that is called as XY diagram. You can refer the following websites for your further assistance. Thank you.